Spirograph, Tales of Wonder. Welcome to the Spirograph, where Tales of Wonder begin. Episode 1, The Big Bang. Part 1. Spirograph style, reverb. Primary pencil color, red.
About 13.8 billion years ago, the universe began with a remarkable event called the Big Bang. At this moment, all matter, energy, space, and even time were concentrated in an extremely small, dense, and hot point. Before the Big Bang, there was no known concept of time or space, because these concepts themselves emerged from the Big Bang. In fact, what we refer to as before the Big Bang is beyond our scientific understanding. Although theories like parallel universes or the cyclic nature of the universe suggest that there may have been states before the Big Bang, there is no concrete scientific evidence for these ideas. In the first 10 to the power of -43 seconds, known as the Planck era, the universe was so small and dense that our standard laws of physics, such as general relativity, were unable to describe it. But soon after, gravity separated from the other fundamental forces, and the universe began to expand. Around 10 to the power of -36 seconds, the universe entered a phase known as cosmic inflation. During this period, the universe expanded at a speed far exceeding the speed of light, and its size grew billions of times in a fraction of a second. This rapid expansion made the universe smooth and homogeneous, a feature that we can still observe today. At the same time, the first fundamental particles, such as quarks and gluons, formed. Around 10 to the power of -6 seconds, these particles combined to create protons and neutrons, the core components of atomic nuclei. Then, within a few minutes after the Big Bang, the temperature of the universe dropped enough for these particles to form the first light elements, such as hydrogen and helium. This process, known as primordial nucleosynthesis, laid the foundation for the chemical makeup of the universe. About 380,000 years after the Big Bang, the universe had cooled enough for atoms to form. This moment allowed light to travel freely for the first time. This light, now seen as the cosmic microwave background radiation, CMB, is one of the most important pieces of evidence for the Big Bang. This radiation represents the oldest light in the universe and gives us a glimpse of the state of the cosmos at that time. After this phase, the universe entered the cosmic dark ages. This era lasted about 150 million years, during which stars and galaxies had not yet formed. However, eventually, gravity caused massive clouds of hydrogen and helium to collapse and form the first stars. These stars, extremely massive and bright, exploded in supernovae, producing heavier elements like carbon, oxygen, and iron. These elements were the raw materials from which planets, including Earth, would later form. Around 9 billion years after the Big Bang, our Sun and Solar System came into existence. Earth, one of the planets in this system, formed about 4.54 billion years ago. The materials that made up Earth were the result of billions of years of cosmic processes and the creation of heavier elements in the cores of early stars. Today, the universe continues to expand, and this expansion is accelerating due to the presence of dark energy. The Big Bang theory not only explains the origin of our universe but also helps us understand that everything we see around us, including ourselves, originated from this cosmic event. This theory not only explains the origin of the universe but also helps us better understand our place in the cosmos and the vastness of the universe's history.